GCE Advanced Level Chemistry Practical number 19, determination of the concentration of a ferrous ion solution with the help of acidified standardized potassium permanganate solution. In this practical, we aim to provide you with the necessary knowledge to understand how a self-indicator works, how to prepare a Fe2 plus solution with a given volume, and at the same time, we'll be focusing on how to carry out a titration to find out the concentration of an Fe2 plus solution with the help of a redox reaction. Without further ado, let's move on to the reagents needed for this practical. Let's take a look at the reagents and the equipments needed for this practical. Here, we will be using ammonium ferrous sulfate to prepare the ferrous ion solution. In your practical book, we have the option of using ferrous sulfate or ammonium ferrous sulfate solid to prepare a ferrous ion solution. Here we are using ammonium ferrous sulfate. Keep in mind, students, ammonium ferrous sulfate has a different molar mass compared to ferrous sulfate. So, when you are measuring ammonium ferrous sulfate, make sure to do the calculations beforehand and measure the right quantity or right mass of ammonium ferrous sulfate to prepare the ferrous ion solution. Then we have 2 moles per decimeter cube concentration sulfuric acid solution. You have phosphoric acid, and we have 0.02 moles per decimeter cube concentration of potassium permanganate solution, which we will be using for the titration. Apart from that, we will be using equipment like 100 cubic centimeters volumetric flask, a funnel, wash bottle containing distilled water, a 25 cubic centimeter volume pipette connected to a pipette filler, which you can operate by squeezing it and generating some pressure in it. I will show you in detail how you can operate it. We'll be using a watch glass, some titration flasks, and some measuring cylinders. As you can see, we have a small and a large measuring cylinder for convenience. We'll be using a digital balance. We'll be using a white color tile to compare the color against the titration flasks. So when you're doing the titration, you can see a very clear color change when you compare it against a white color background. So to do that, we have a white color tile. And connected to a retort stand, we have our burette. So we will use this burette to slowly add small quantities of potassium permanganate into the titration flask to carry out the titration. So these are the equipments and the reagents you will be using to do this practical. Let's move on to the practical. Students, let's start our practical. In order to move along with our practical, we need to first make a ferrous ion solution. To make a ferrous ion solution, we can use ferrous sulfate solid or ammonium ferrous sulfate solid. So over here what we have is an ammonium ferrous sulfate solid. So we will take this ammonium ferrous sulfate compound and we will measure 4.5 grams of this ammonium ferrous sulfate and transfer it into a volumetric flask like this. The volume of this volumetric flask is 100 milliliters, and then we will form a solution with the use of 4.5 grams of ammonium ferrous sulfate. Now without further ado, let's move on to measuring that amount. we will take our watch glass and we will place it on our digital balance over here. As you can see, we can see a reading for the mass of the watch glass. We do not need to know the mass of the watch glass because we will be tearing it. So when you press the button tear, the mass of the watch glass will be disregarded. So from here onwards, whenever we add a little bit of ammonium ferrous sulfate onto the watch glass, only the mass of ammonium ferrous sulfate will be recorded here on the digital balance. So now let's move on to add ammonium ferrous sulfate onto the watch glass. We need to measure 4.5 grams of it, actually 4.50 grams of it. We have to be very careful not to spill anything onto the surface of the balance over here, because if you spill anything onto the surface of the balance, what happens is when you remove the watch glass, you are not taking the granules that you have spilled onto the surface, but you calculated the mass of those granules when you were measuring 4.5 grams of ammonium ferrous sulfate. But once you remove the watch glass, you are not taking the granules that are on the surface of the balance, which means you are not transferring the correct amount of the solid onto the volumetric flask. So do not spill anything on the surface of the balance. You should put whatever the solid that you put onto the watch glass. Now we have successfully measured exactly 4.50 grams of ammonium ferrous sulfate. Let me put the ammonium ferrous sulfate bottle away. Now, since we have measured exactly 4.50 grams of ammonium ferrous sulfate, we can now transfer it into our volumetric flask. Now, when you are transferring a solid onto a volumetric flask, you have to be very careful. You should make sure that none of those measured sample is spilled. Now we no longer need the balance, so we will keep the balance aside for the time being. So to make sure you do not spill anything, we have to take a funnel like this. You can place the funnel on the volumetric flask, and then you can take a measured amount of the solid over here and transfer it with the help of a wash bottle. So what you are going to be doing is you will be transferring some distilled water onto the surface of this solid, so that solid will dissolve a little bit over here and will get transferred onto the volumetric flask. So let's go ahead and do that. After you transfer all of the solid with the use of the wash bottle, I want you to turn the watch glass the other way and then wash the bottom bit of the wash glass with some water, so that any remaining solid will actually get washed into the volumetric flask. Now it is time for us to add a little bit of 2 moles per decimeters cube sulfuric acid. So let me take a measuring cylinder and measure exactly 50 cubic centimeters of sulfuric acid. Whenever you are measuring a volume, please make sure that after transferring the right amount of volume, to raise whatever the measuring equipment and keep it at your eye level so that you can see the gradient lines and the meniscus of the solution aligning with the gradient line. If you do not check that, sometimes your meniscus and the gradient lines might not be properly aligning and you might be measuring wrong amounts of volume. Now students, we'll try our best to swirl this a little bit and dissolve all of the ammonium ferrous sulfate that is there. And while doing so, let's add a little bit of sulfuric acid as well. This will help dissolve our ammonium ferrous sulfate. Little by little, we will add sulfuric acid. We have to add exactly 50 cubic centimeters of sulfuric acid. Now we can see the solid that is in the volumetric flask is starting to dissolve. It's almost entirely dissolved, so now we can add the entire amount of the remaining sulfuric acid. After adding the remaining sulfuric acid, you can see still the total volume of this solution in the volumetric flask has not reached the gradient line that is present over here. So we now have to very carefully start adding water little by little until we reach that gradient line. So to do this, we can use a wash bottle like so, and I will squeeze very gently the wash bottle and transfer small amounts of liquid, small amount of water into this volumetric flask. As you can see, now I am almost there near the gradient line over here. Once you have reached that point, you will no longer add water using the wash bottle. Instead, you will be using a dropper so that you can carefully add correct amount of water or small quantities of water without exceeding the gradient line that is present in the volumetric flask. Now let's take a dropper. Now let's take our water beaker and add some water onto it, distilled water onto it using our wash bottle. Now using this water beaker and the dropper, I'm going to add small amounts of water onto this solution. So we have to be very careful when we're adding the last bit of water. So now I have to bring this up to my eye level and add little amounts of water until the meniscus is aligned exactly with the gradient line. So now I have reached that point where the meniscus of this solution is aligning exactly with the gradient line. I think I can add one more drop of water. It's not quite exactly where I want it to be. Now the bottom of the meniscus is aligning exactly with the gradient line. So let's take a closer look at that. I hope you can see that the meniscus is aligning with the gradient line that is present on the volumetric flask. Now after filling up water up to that level, we have to mix it thoroughly. In order to do that, we can take the stopper of the volumetric flask. You will place the stopper tightly and you can turn this volumetric flask upside down like this a couple of times to make sure the solution is mixed thoroughly. So we'll do it a couple of times like this. Right? So when you do that, you have to make sure that the stopper is tightly closed, otherwise some solution will spill over. We don't want that to happen. Now we have successfully prepared our ferrous iron solution using ammonium ferrous sulfate, 2 m or 2 moles per decimeters cube concentrated sulfuric acid and distilled water. Now let's move on to our titration. This practical focuses on titrating iron 2 plus iron solution. Whenever we are doing a titration, we have to know how to use a burette. So let's first focus on how we can clean a burette and then how we are going to fill a burette up. So what we have here is a burette connected to its retort stand. And before we use this burette, we have to make sure that it is washed with distilled water, and then we have to wash it again with the solution that you're going to fill into the burette. This is to make sure that the droplets of water that is remaining inside the burette does not dilute the solution that is being added to the burette. So to make sure that it is not going to change its concentration, whatever the solution that we add here, that it is not going to change the concentration, we will have to wash this burette twice, once with distilled water, and second time we are going to use the solution that we are adding to this burette and we are going to wash it again with that solution. So let's move on to washing this burette. Whenever you are trying to use a burette in a lab environment, one of the mistakes that I have seen a lot of students make is that they will keep the burette and the retort stand on the lab desk itself, and then they will place a funnel on the burette which is over their head, and they will take the solution and lift it again over their heads, which is a bit of a risk in the lab environment, because if you spill it while it's over your head, it will directly get spilled on your face. So we will not do that whenever you are filling a burette. So what you do is you find a stool or a table that is shorter than the lab table, and we will move the burette onto that table. So now the opening of the burette is going to be below your eye level. So now you can take a funnel and place the funnel on the opening of the burette and wash or actually transfer some water onto the burette. While doing so, please make sure the burette tap is closed. Now I will be adding a little bit of water onto the burette. After transferring some water, I'll transfer some more. Uh, After transferring some water onto the burette, to show you all what needs to be done, I'll bring it back onto the lab table. You will take a beaker and open this tap rapidly, making sure the tip of the burette is also cleaned with distilled water. And then we will remove the burette from the retort stand, and then we'll make sure that we don't spill a lot of water. And then we'll turn the burette sideways and wash the interior walls of the burette by rotating the burette like this. So while doing this, you can remove the water onto another beaker to discard the water that was used to wash the burette. You can open this end to make sure all of the water in the burette is removed. So that is how you would normally wash a burette using distilled water. This is just the first step. After using water and washing it, we will have to use the solution that is going to be filled into this burette and wash this burette again with that solution. So let's move on to that. So in order to do that, I will take the retort stand again and fix this burette like this. And then transfer some of the solution that will be used to titrate, or that will be used to fill this burette in the titration. And now again, I will have to take this burette onto a stool that is shorter than the table over here. And I will use a funnel again to transfer some of this solution into this burette. Again, when you're transferring any liquid into the burette, make sure that the tap or the burette tap is completely closed. Otherwise, while you add, you will be making a spill due to the tap being open. Now I will move this back onto my table. Just like in the previous setup, I will open this tap and make sure that the tip of the burette is also fully cleaned. So I will open it rapidly, allow some solution to run through. So now I know even the tip is completely washed. Afterwards, I can remove this burette from the stand and continue to wash it like I washed it before. So let's remove the burette from the stand. Now, like in the previous example, I will be turning this sideways like this and making sure the entire interior surface of the burette is completely washed properly with the solution that is about to be filled into the burette. With this, the washing of the burette is complete. One additional step would be to open the burette and let the remainder of the solution run through. Now, burette is completely washed. We can move on to the experiment. After washing the burette, we will again fix it onto our burette's retort stand, and we will move it back onto a shorter table. Since the washing of the burette is complete, now we will be filling up the burette with a solution that goes in the burette, which is 0.02 moles per decimeters cube concentrated potassium permanganate solution. So let's add that solution onto the burette. So for that we will require a funnel. We will place the funnel over here. So after placing the funnel, let's take another beaker and transfer some of the liquid or the sample that we need to fill into the burette. Let's take about little over 50 milliliters because the burette can hold only 50 cubic centimeters. And now, after making sure the burette tap is closed, we will start adding the potassium permanganate solution into the burette. When you are filling a burette, please make sure initially when you are adding the solution to add the solution over the zero line. The reason for this will be clear to you in just a second. After adding the potassium permanganate solution over the zero line, you can see that this tip of the solution is still empty, or tip of the burette is still empty. So we need to fill that area as well. So what we do is we open this tap rapidly to make sure that area is completely filled. Now I wanted to show that to you. That is why I brought the burette onto the table again. Now we have to make sure we keep it at eye level and bring the solution down onto the zero line. So let's do this together. So in this burette, we have the solution level above the zero line, and we have to make sure that the meniscus of the solution over here aligns with the zero line of the burette. So especially when it comes to a dark colored solution like this, finding the zero line could be difficult if you are doing it in a dark environment. So please make sure that you have some sort of light source behind the burette so that you can place or find where the zero line is easily. So let's open the tap of the burette and bring the solution line down to the zero line. And please notice that I try my best to keep my eye level with the level of the meniscus. This is done to make sure that the meniscus and the zero line are aligning perfectly. The zero line is over here. I'm not sure whether the camera can capture the meniscus, but meniscus is aligning with the zero line that is present in the burette. Right. So now I have removed some solution and made sure the meniscus of the solution is perfectly aligning with the zero line of the burette. With that, we have finished. With that, we have actually now finished filling up and cleaning the burette. Now the burette is set up for our titrations. Now we will be moving on to filling up our titration flasks to carry out the titration. Right, students? Now let's move on to filling some titration flasks. But before we do that, we need to take a pipette and learn how to use a pipette. Right, so this pipette is connected to a pipette filler. This is how the pipette filler looks like. So we need to first of all learn how to clean the pipette and then how to fill the pipette. In order to first of all clean the pipette, we need to fill it with distilled water first and then remove that distilled water, and then later on again wash it a little bit with the solution that we are going to be taking into the pipette. So we have to, just like we did with the burette, we will have to wash it twice, once with distilled water, and the second time we have to wash it with the solution that you're going to be filling into the pipette. So pipette, I have seen in certain labs, certain students, I have seen them filling it with the use of their mouth and creating suction with the mouth. That is extremely dangerous, especially in the lab environment. All the chemicals that you have in the lab, you can consider them to be harmful to your health. So you should never place your mouth on any lab equipment. So to fill the pipette, we have something called the pipette filler. This is what we know as the pipette filler. So over here you have a bulbous section of the pipette filler, which can be squeezed to release air in this area. So in each of these places you have valves. So you can actually squeeze the top valve over here and then remove the air inside this bulbous area and then remove your finger. This will create enough suction for us to draw liquid through this area when it is connected to the pipette. So let's see how we do it. We will connect the pipette filler onto the pipette, and since we are going to be using distilled water to wash it first, we will take a little bit of distilled water onto a beaker like this, and now we will place the pipette tip in the beaker like so. When you are trying to fill the pipette with distilled water, we can first press this topmost part of the pipette filler and then squeeze this bulbous area a little bit, and then if you release it and then press the second section over here, it will draw in some water like so. Now after you draw in a little bit of water like this, if you wish, you can remove the pipette filler and move on to cleaning the pipette. So once you remove the pipette filler, make sure to keep your thumb over the opening of the pipette. This will allow the liquid to remain in the pipette. Otherwise, once you release the thumb, if you pay close attention to my thumb and the liquid level over here, once I release the thumb, you can see the liquid inside the pipette will be transferred into the beaker again. So now, after filling the pipette like this, you will have to turn it sideways, and you can swirl it around like this, or actually rotate it around like this, and coat the interior walls of the pipette with distilled water. And the remainder of distilled water can be removed from the top of the pipette like this. So with this process, we are done with the first wash using distilled water. Now we can move on to washing it with the solution that we will be filling it with, which is our ferrous iron solution. Over here we have the ferrous iron solution that we prepared a while back. We will take a small amount of our ferrous iron solution into this small beaker. And then we will repeat the same washing process as in the previous example. Now you can see I have taken a little bit of the solution into the pipette. I will now turn it around and wash it carefully and let go of the solution after it has coated the entire interior wall of the pipette. So now we have successfully washed our pipette with distilled water, and then later on with the solution that we used to fill this pipette with. Now let's go and prepare our titration solutions. Students, let's start our titration now. So initially we have to measure 25.00 cubic centimeters of our ferrous iron solution, which means we need to make sure the accuracy of the measurement is quite high. So in order to do that, we will be using an equipment like the pipette, which has high level of accuracy. So using our pipette filler, we will take 25 cubic centimeters of our ferrous iron solution, and we'll transfer it into our titration flask. As you can see, we are filling it up, and once you have filled it up, you can use your thumb and bring it up to see if it is in the right level. So if you can take a look at this liquid level, it is exactly at the right position, and meniscus of the liquid level aligns perfectly with the gradient line, meaning that we have accurately measured 25.00 cubic centimeters of the ferrous iron solution. Now let's see how we transfer the solution into this titration flask. The tip of the pipette should touch the interior walls of the titration flask. So you have to slant the titration flask like so, and then after you make sure the tip of the pipette is touching the titration flask, we can let go of our thumb, allowing the liquid to flow into the titration flask. Now all of the liquid has moved into the titration flask, and now you will see me taking the pipette out. So if you observe closely, At the tip of the pipette, there is a liquid drop still remaining. This pipette is calibrated in such a way that it is accounted for. It has accounted for this drop over here. So you are not supposed to blow it into the conical flask or the titration flask. If you do so, you will have a different reading. So please make sure that you don't have to worry about that droplet that is present on the tip of the pipette, and you are not supposed to somehow force it into the titration flask. Please make sure not to do that. And then we have to add 25 cubic centimeters of 2m sulfuric acid. Now this measurement does not have to be as accurate as the ferrous iron measurement, as we are not titrating the H plus concentration here. We are titrating the ferrous iron concentration. So we need to make sure the ferrous iron volume or solution's volume that we have taken is highly accurate. But when it comes to transferring acid, we do not have to worry about the accuracy that much. So we can resort to using a measuring cylinder such as this. So let's measure 25 cubic centimeters of sulfuric acid. Now this sulfuric acid has a concentration of 2 moles per decimeters cube. We have measured 25 cubic centimeters of sulfuric acid, and now we will add it to our titration flask. Apart from the sulfuric acid that we added, we have to make sure that we add a little bit of phosphoric acid as well. Let's take a small measuring cylinder, because we are only supposed to add 5 cubic centimeters of phosphoric acid. So we can use a small measuring cylinder like that to measure 5 cubic centimeters of phosphoric acid. You will use this acid over here, and we'll use this measuring cylinder we have measured 5 cubic centimeters of phosphoric acid, which we will now be adding to our titration flask. Now let's swirl it around a little bit to mix all the components together. With this, we have prepared our solution for our titration. Now we can go ahead and titrate this solution. Let's move on to our titration. Over here, we have our solution in our titration flask, and we have our burette filled with 0.02 moles per decimeters cube concentrated potassium permanganate. So now all that is left for us to do is to titrate this solution to find out the concentration of Fe2 plus ions. So we will move this titration flask underneath this burette, but before you normally do so, please make sure that the burette reading is at 0. That means the solution meniscus of the burette is aligning perfectly with the 0 line of the burette. After making sure that it has aligned with the 0 line, we can place our titration flask right underneath the burette. Now, we will use our less dominant hand. Actually, our dominant hand will be used to mix whatever the solution that comes into the titration flask, and our less dominant hand will be used like this to control the amount of potassium permanganate added into the titration flask. So when you're holding the tap of the burette, please make sure to hold the tap from the opposite direction, wrapping your hand around the burette so that you don't make any sudden moves. And at the same time, please do not handle the burette tap like this from the same side, right? So you're supposed to hold it like this. And now let's start adding potassium permanganate little by little into this solution. Now if you can see, as soon as potassium permanganate enters this solution in the titration flask, the color of the potassium permanganate disappears. The reason for this is over here we have KMnO4, and the color of this potassium permanganate is due to MnO4 minus ions. So these MnO4 minus ions, as soon as they enter the solution in the titration flask, they will react with the Fe2 plus ions and will oxidize the Fe2 plus ions into Fe3 plus ions. So when this oxidation takes place, the MnO4 minus ions will get reduced to Mn2 plus, which will appear colorless in this solution. So that is why as soon as a droplet of potassium permanganate is added into this medium, the color of potassium permanganate disappears and it will appear a clear solution. So we will continue to add very cautiously potassium permanganate into this solution, and when you are adding this drop by drop, please make sure to keep mixing it quite well, like I am doing right now. So right now, as soon as the potassium permanganate drop hits the solution, you can see the color of that solution completely disappears. It doesn't take that long for the disappearance to take place, which means we are nowhere near the end point. So the closer we are to the end point, the time taken for the color of the potassium permanganate to disappear will take longer. So that will serve as an indication that we are close to the end point. And please make the observation as I start pouring potassium permanganate drop by drop into the solution in the titration flask, the liquid level of the burette also keeps going down, right? So you have to pay attention to that as well, because this is going to be your burette reading. Now right now I'm at 8 cubic centimeters of potassium permanganate. That means I have added around 8 cubic centimeters of potassium permanganate into the titration flask. So I will continue to keep adding potassium permanganate into the titration flask while swirling it around like this. As you can see, little by little, I'm adding and I'm mixing it up to make sure that I am not adding too much of potassium permanganate. Because if you keep the tap open at one point, the reaction will go to completion, the right amount of potassium permanganate and Fe2 plus will react, and then you will add additional amount of potassium permanganate into the mixture. So you will not properly notice the end point. So you always have to make sure you add little by little until you get close to the end point, And once you have realized that you have gotten quite close to the endpoint, you can start adding potassium permanganate drop by drop. Now, if you take a look at this solution over here, when I add a little bit of potassium permanganate, for the color to disappear, it will take some time. This is an indication that we are closing in on the end point. So now I have to be a little bit more careful when it comes to adding potassium permanganate. So I will be adding it drop by drop into the titration flask, mixing it quite vigorously. I am getting a feeling that we are very close to the end point. So I will tell you what to observe at the end point. As I mentioned earlier, this is a redox reaction where potassium permanganate or permanganate ions react with the Fe2 plus ions and convert Fe2 plus into Fe3 plus. And due to this oxidation, potassium permanganate will reduce into Mn2 plus, or permanganate ions, MnO4 minus ions will reduce into Mn2 plus, which is colorless. So the purple color MnO4 minus ions will reduce into Mn2 plus ions, which is colorless, and that is why we keep seeing the color of the potassium permanganate disappear as soon as a drop enters the solution. At the end point, however, you will notice when you are reaching the end point, the amount of Fe2 plus in the medium will decrease, and at one point all of the Fe2 plus will convert into Fe3 plus. And then the next oncoming drop of potassium permanganate will not have any Fe2 plus for it to react with. So therefore, the color of MnO4 minus will remain. It will not undergo any reduction to turn into Mn2 plus. So therefore, the MnO4 minus ions color, which is the purple color, will remain. So you can see a persistent pink color because there's a lot of solution over here and only a drop of MnO4 minus ions will be entering the solution. So you will not observe a very dark purple color like this. It will be a slight hue of that color. So you will observe that color in the titration flask. So at that point, that color will not disappear, and then at that point, we will realize we have reached our endpoint and all of the Fe2 plus ions have reacted with the MnO4 minus ions. So let's get to the endpoint now. Now students, we have obtained a permanent pink color that does not disappear for 30 seconds, actually 30 seconds or more. So this is our end point for this particular titration. And now at this point, you can take the reading of the burette. So the burette reading is at 25.8. Our burette reading is at 25.8. So at that point, we have obtained a permanent pink color in the solution, giving us an idea that the reaction has gone to completion, or as the titration is now complete, that all of the Fe2 plus ions that was present in the medium is completely reacted to form Fe3 plus ions. So the oncoming potassium permanganate or permanganate ions, MnO4 minus ions, turned this entire solution into a slight hue of pink. So after we are done with a titration such as this one, we need to replicate the same titration 2 more times so that we can get an average value for the titrate volume. So after completing the first experiment, we will go on and do this same titration 2 more times to get 2 more readings, to be very clear about the titration and to get very clear readings so that we will know that our reaction has been done correctly without errors. If the readings are quite close to each other, we can determine that our reaction has been precise, or the readings have been precise, so that we can move on to the next step of calculating the concentration of the Fe2 plus ion solution. So now let's move on to the second titration of Fe2 plus ion solution. Now we are moving on to the second titration. So basically we are repeating the same titration 3 times, or actually 2 times. So this is the second time we are doing the same titration. We have prepared the solution as we did before, and we have topped up our burette with the same potassium permanganate solution, 0.02 moles per decimeters cube concentrated potassium permanganate solution. We have filled it up to the 0 level of the burette, and now we can move on to continue our titration. We'll adjust the burette a little bit so that it will be comfortable for me to handle it. Now students, we have already done this practical once. So we know where we are going to be obtaining our endpoint. That is somewhere around 25.8 centimeters cube of potassium permanganate. So since we know the endpoint, we can actually speed up this titration by adding potassium permanganate a little bit faster than we did before. And then closer to the endpoint, we will slow down the addition of potassium permanganate and very slowly start to add potassium permanganate drop by drop into the titration flask to obtain a very accurate endpoint. So let's start with that titration. So before we do, we'll have to lift this up a little bit. I will feel a little bit more comfortable having it at a higher height. Now we will be adding potassium permanganate. As you can see, now I'm not adding potassium permanganate that slowly. I'll be adding it somewhat faster. Now potassium permanganate and Fe2 plus reaction is a redox reaction, as you may have heard of it before. And at the same time, potassium permanganate acts as a self-indicator. Why do we say it's a self-indicator? We can see that we did not use any additional indicators for this reaction. At the end of the titration, potassium permanganate itself acted as an indicator and gave us the endpoint. So that is why we call this a self-indicator. Now, by now I have added 17 cubic centimeters of potassium permanganate. I will add a little bit more potassium permanganate and then start adding potassium permanganate slowly. Now we add 23 cubic centimeters of potassium permanganate. Now let me add potassium permanganate a little bit more slowly so that we can obtain a more accurate endpoint. Now we have obtained our endpoint at 25.9 cubic centimeters. So the second titration reading was 25.9 cubic centimeters. With that in mind, we can move on to our final titration and get our 3 readings that we will need to continue on to the calculations to find out the concentration of Fe2 plus solution. Now we come to our final titration. We have repeated the same titration twice. This is going to be our third titration. We have our solution over here. We have our burette filled up to the 0 line. Now we will once more carry out this titration to obtain another set of readings. As I did before, we know that the titration will give us an end point close to 25.8 cubic centimeters. So I can start adding potassium permanganate at a fairly fast pace so that we can expedite this titration a little bit. And then once we are close to 25 cubic centimeters, we can slow down and start adding potassium permanganate drop by drop. Now I am at 23 cubic centimeters. Now let's slow down. We can see that the color of the solution is now a permanently pink color or very light purple color. So at this point, we can say that the titration has reached its end point. So the reading at this point is 25.9 again. That was the same reading as our second titration, and our first titration reading was 25.8. Now we can see that these values are very much close to one another, meaning these titrations or the readings that we obtained through these titrations were concordant. They were within 0.2 cubic centimeters of volume. So that means these titrations or the volumes that we obtained through these titrations were concordant. Now, with these results, we can move on to calculating the concentration of the Fe2 plus ion solution we prepared in the beginning of this titration. Let's move on to the calculations that are revolving around this particular experiment, where we'll be using the titration volumes to calculate the concentration of the Fe2 plus ion solution that we prepared in the beginning of this practical. And afterwards, let's move on to the important theory parts related to this practical.